Hello students, let's look at Edexcel GCSE Computer Science Paper 2 for 2025. It's half your GCSE, 75 marks, and let's make sure that we show best practice when we have these files open. Student coding, as soon as you open this Python file in whatever program you're using, like Thonny, just save the file as like Q01 finish with no gaps and uppercase, and just get that done, so that you can not change the original Python files, which is not what you're meant to do. Put them into completed coding, and then you can refer back to the original Python file if you make a mistake. It's the best practice, and you can avoid issues or panics and lost files during the exam. So let's look at question 1. 10 minutes suggested. You've got 2 hours for this exam, 9 marks, about a minute a mark. You've got how many bullet points? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so essentially it's a bullet point per mark. The program calculates a discount based on the number of 2-course meals, 3-course meals and drinks ordered by the user. When the total number of meals exceeds 8, a 15% discount is applied. When the 3-course meal exceeds 4, 10%, and when the number of 2-course meals exceeds 2, 5% discount. Only 1 discount is applied. Fine. So the code's pretty much done for us. When the number of drinks does not match the total number of meals, an error message has occurred. So we've got some issues here. Let's fix a syntax error on line 4. Well, the comment wasn't with an octothorpe hashtag. That's the simple one there. Fix the syntax error on lines, and just as you go, just highlight the ones you didn't, tick them off as you go. Fix the syntax error on line 6. You can't have variable names with gaps, so I'm just going to remove that. And it should be cost drinks, that's what it should look like. Fix the syntax error on line 10. I mean, it's literally the wrong way round, so it should be number of drinks equals 0. These are 4 easy marks off the bat, 3 marks. Line 28, fix the type error. Right, so we've got a string times something else, cost for courses. And if that was an integer, you can actually can times a string by an integer, but it's not what we need, is it? So line 28, we just need to get rid of the string. So we've got number of courses times cost for 2 courses. 4 marks done. Fix the name error on line 29. Cost 3 courses. There we go. Fix the name error on 38. Total. Spelt wrong. And it's literally, Thonny's trying to show us where all of those variables have been listed, which helps you. So we're happy with that, and you can kind of see visually where the issues are. Fix the logic error on line 33. So this might be a little bit more tricky. Let's have a look. Where's line 33? Okay, if number 2 courses minus number 3 courses is greater than 8, I think what it said here, it should be plus instead of minus. Yeah. When the total number of meals exceeds 8, so it should be plus. Fine. Fix the logic error on 34. So total equals total. Yeah, why is that plus total and all the others are times? So 0.85 is getting a 15% discount, so that should be times. Then fix the logic error on line 40. Total, we've got, no. I think that should be indented. And that's the issue. How many 2-course dinners? Let's just say 3. 2. How many drinks? 2. Meals and drinks don't match. Yeah, okay. Let's just try again. Don't know, but 2, 2, 2. Meals and drinks don't match. I think it's all fine. Yeah, I'm going to move on. I think we've done all of that. Happy with that. Question 2. Countdown for a rocket launch. Okay. Immediately I'm thinking of the range parameter to go down instead of up. Start stop step. The program counts down from that number, or the wait time between each count is 1.5 seconds and stored in the code. Here's the output. So we expect it to be, what is the countdown? 3, 2, 1. So we're entering 3. The person will enter that. Then it'll be 3, 2, 1, and then ignition liftoff. So we need to import the time library. It's in your PLS subset document. You literally just need to import time. Done. First one ticked off the list. Don't overthink it. We can use that for time.sleep. I think that's the only reason we'd use time. Create a variable named countdown and set it to 0. Fine. I mean, it really... Complete the line. Is it that easy? Global variables. So I'm just going to copy that. I double click on that and set it to 0. I think it's as simple as that. Yeah, I don't want to overthink it. Global. It's very typical that we have modules, constants, global variables, subprograms, and then the main program. That would be how you would structure Edexcel GCSE exam questions. Take the input from the user and convert it to an integer. Fine. So we want to make sure it's whatever we put in is an integer. It's going to be input statement, and then we're going to use. So what is the countdown? Always put a space, otherwise they put their own spaces and it causes issues. Complete the line to ensure the number input is valid. So user inputs between 1 and 10. So as long as it is less than or equal to 10 and countdown is greater than 0, then we're okay, aren't we? When it can complete the condition to ensure the loop stops when it reaches 0. So essentially, while countdown does not equal 0, it does not equal is this. As long as it does not equal 0, we can keep on doing something. That's our condition controlled loop. Add a line to display countdown for the user. Fine. So literally just print countdown. Double clicking, so I don't want to mistype it and waste time. Complete the line. So here is we have sleep. This is the method that we can use within the sleep module, and we've got a wait time already that in the constant. So I'm going to copy that and put that in the brackets as the parameter. And then finally, countdown. We want to take away 1 from it. So I'm just going to double click, countdown -1. So we update the value of our countdown and take away 1 from it. Add a line to display ignition liftoff. So I'm just going to copy that. verbatim. And I just want to make sure that it's not in my for loop. I only want to do this bit on the countdown, and then finally outside of the loop print ignition liftoff. Let's run it. We've got Houston, we have a problem. What is it? Okay, indentation error. Let's just try tabbing that in. Let's do 3, 2, wait 1.5 seconds, ignition liftoff. Perfect. That's exactly what we saw here, and that's what we want to replicate when we're running our program. Let's move on. Right, we need to put the constants and we need to put the global variables in here. Plus it looks like we've got a whole load of stuff in the wrong order. So this is going to be a bit of a mission. It's fine, we can do it. So the program allows the user to enter a string. Okay, if the string is fewer than 3 characters long, an error message. Okay, so it looks like we don't have to make these at all. They're already done for us. They're already made. It's just that the whole lines of the code are jumbled up. So what we immediately should just say, okay, well, anything to do with capital letters, we're just going to cut, put it over here. And if you want to, just underneath, make a triple quoted string and pop the code in there so you can see what it was like when you got it, and you can always delete that afterwards. So I'm going to put all of these up in I'm going to make sure I cut them with Control or Command X. I'm using a Mac. Control X, so I don't want them languishing around. I'm pretty sure we've just done the first bit. Our constants are in the right place. And then our global variables are going to be like things like total equals 0 that we don't have the total yet. So I'm going to already start putting that up here. What else? In string as an empty string. It's very likely that's going to be up here. Do we have anything? ASCII value? Yeah, it's all on the left hand side. All of those are global variables. Yeah, and I haven't even properly read the question yet. Otherwise, the program adds up ASCII values for each character in the string when the total is divisible for all. All right, okay, so we will need to read through how this is meant to work in a second, but just by using some logic, I'm deducing where these are meant to go, and then suddenly I'm looking at something that's a lot less annoying, basically. Set up the input loop. Okay, well that is going to be higher up, isn't it? That's going to be a lot higher up. So I'm going to enter a string blank to exit. So, I mean, it's literally the first thing that happens. A program allows the user to enter a string. So actually all of this is up here. All of that's up here. Because we're going to have a loop at some point. I'm pretty sure that comment's in the right place, but we can always change it if need be. But that is definitely in the right place. If the string is fewer than 3 characters long, an error message. Okay, so all of these now, can you see they're all indented? So the only thing that's not indented is the while loop. So that tells me that this while loop is got to be the next thing. And it makes sense that there's comments there as well. And we're getting in string from the user, and now we're setting up as long as in string does not equal an empty string. So at the moment it's initialized an empty string. the user enters something, so it's not an empty string. If it's blank, to exit. So if they don't put anything in, it will be blank, and that would stop the while loop from working. Okay, so now, if the string is fewer than 3 characters long, so where is that? Again, the indentation is here, so the if and else are going to be one indentation in. Like, if we did a character return here, it would go in. So that is definitely going to be here. It's got to be. If the length of the string is greater than or equal to 3, an error message is displayed and the string is not processed. So let's have otherwise a program. So the error message will be under else. So where's the error message? String must be 3 or more characters long. So that's going to be under else. Let me just check it's in the right indentation. Yeah, it is in the right indentation. So I'm just going to cut this. Yeah, there we go. String must be more than 3 characters long. So that's the else part of our validation. If it's greater than or equal to 3, then we're okay. And the rest of the program will work. Else, string must be 3 or more characters long. And then the only other thing, all of this stuff has got to be in the if statement. So I'm going to pop it up here. I don't know exactly where it will be yet, but enter a string blank to exit is the last thing that will happen in the while loop. That's the problem. Okay, I've got to make sure that's indented properly. That's why I think this was a good idea. I can make sure they're all indented properly. In string, yeah, get rid of that. I didn't cut it. Right, it's looking a little bit better now. Is it? No, I've lost something. Here. Right, now I think it's okay. Right. So if the length of the in string is greater than or equal to 3, something is going to happen here. Else, string must be 3 or more characters long. Fine. And then before the loop goes, we want to ask enter a string blank or exit for the next round of the loop. So I'm happy with this so far. I'm pretty sure these are okay and that's okay. So what I need to do now, it kind of makes sense to check to have total equals total 0 at the beginning, and then we're not ready to update our total yet and it's indented. So what we want to do, the program adds up the ASCII values for each character in a string. So we have to iterate over each character in a string. There we go. Literally says for each character in a string. So let's put that in. For character in a string, and then we've got to do something with ord, because ord is where you can get the order of the character, which, like, for a capital A, that's 60 in ASCII, isn't it? So that will be, it would make sense for character in a string, get the order of that character, and that will be the ASCII value. And then we want to, yeah, there, and that's in the right place. Total equals total plus ASCII value. So our for loop, and then when the total is divisible by 4, so if total modulo 4 does equal 0, a 4 is added to the string. So I think it's this bit here, in string is 4. If total divisible by 5, else if, so I'm just going to cut this, making sure it's in the right place, else if total 5, we can add 5 to the string. When total is, so else, I guess, when the total is divisible by both 4 and 5, else if, yeah, 4, 5, I think we're happy so far. That resetage pass, that's going to be up here, isn't it? Indented a bit. Else if when the total is not divisible by either 4 or 5, so that's going to be else. That's the only thing we can do, isn't it? Then we add 0 to the string. So, I mean, this is all the stuff they've given us, and then we can just print the total is in string. And let's just delete all this. We don't need that for reference anymore. That was helpful though. I'm glad I did that. And the best thing to do is just run it. So enter a string. So I'm going to enter X. String. Okay, that's what we expected. Cup. Yeah, okay, it works. So just put some of these in there and make sure that it behaves. If I put a blank in there, it will exit the program. Quite tricky, bit of a tricky one for question 3, but all the code is there. It would just take a bit of poking around, a bit of logic. I mean, getting these out of the way really helped, and then reading through this in order. The bit was a bit confusing is that when the total is divisible by both 4 and 5, 4 is added to the string, because we don't really have like another statement combining both of those together. But anyway, this is what they gave us. Let's move on. Multiplication square. Okay, if the number is 10, the intersection of the row. So this is probably going to be a nested for loop. Oh, it is. Look, there you go. For rows and columns. The user enters the number of sides for the square, and then calculate the values for the multiplication square. Write the values to a new file. Okay, we're writing to a file on question 4. Fine, okay. And we know if this works because this is what our output file will look like. Okie doke. So we've been given a little bit of code, but we've got to do quite a lot ourselves. The LF stands for line feed, and that's a new line character. And we've got commas that we can concatenate an out string. So it's typical that you need to say out string to build up a string to write to the file, the text file. So we've got our global variables, we've got our constants. Open the output file. So this is in the PLS subset document. So I can say the file equals open, and we can make sure that it's in write mode, comma, and we've already got the output file saved as a constant. So I'm going to pop that in there. This will create a file if it doesn't exist already, and if it did exist already, it will remove anything that was in there. So that is in the PLS subset document, so you can get a mark for free there. Just make sure that sometimes it might look like this if we didn't have it written in a constant, but we do. Okay, so let's go through. Enter a number, get the number, fine. For row in range of 1, max number, which is 0 plus 1. This is a start value and a stop value. That's fine. We've got an empty out string. That makes sense at the moment because we want to build that up. So we need to, once we're looking at the rows, we look at each field, each column entry, and we need to be putting that in indentation. If we did an indentation here, it would take us down, but we've got all these comments, so just be careful. Actually, you can waste a lot of time if you put things like, say, here. So the number that we've got as a global variable, if we're looking at a row and column, is going to be our number that we're looking for row and times that by column, because that's going to be a number and that's going to be a number. And like, so, 1 times 1 is 1, 1 times 2 is 2, etc., or 2 times 3 is 6. So that's where this calculating a new value comes from. And then we want to create a new value, and we want to build that to our out string, don't we? So out string equals whatever's in the out string plus a concatenate, join together, a string version of the number, because it'll be an integer and we want to change it to a string in order to concatenate to an empty string. Good, let's add a bit of white space here. So it does say use the constants, variables in the existing code provided, don't do anything else, don't add extra, anything else in there. Add a comma to all except the last column. So we've got max number, I think that's going to be in there, and column. So I can put, it's an if statement, it's going to be, because it's based on a condition, isn't it? If our column is less than our max number, then we can build up our out string, can't we? So out string equals whatever's in the out string plus, and we've got the comma added to a constant here as a string. It does make it a bit cleaner. So we're concatenating a string to it, a comma. And then it would be add a line feed to the last column. So that would be else. I guess it would just be the only other condition, as long as column is less than the max number. If it is the max number, then we want to add our line feed, LF, to it. So that would be the last line, the max number. So it's whatever that number they type in, that's the maximum number. That's like, if it's 5 in this case. Because if we get to 5, if we get to 5, we want to add a line feed at the end of a line. Write the row to file. Okay, fine. Well, let's do close a file. That's easy. So just the name of the variable, and then we've got the close method. That's the nice easy mark. Write the row to a file. So we want to make sure that's not in this for loop. So it'll be indented in. So once we've done our column, we're still in the for loop here for row. We want to write the row. So we're going to do the file dot write, and in the brackets our out string, which we've started off as empty, and then we've been building up as we go. And let's just enter a number. Let's do 5 because I want to be exactly the same as what they've given us. Now the only way we'll know this is if we actually check the output file, and it does work, thankfully. We've got the same as what they've done. Good. I think I'm happy with that. Let's move on. Wow, okay, what's going on here? Turtle. So we haven't imported the turtle library, which is a bit of a problem. That's an immediate mark. Let's have a random integer. 9 colored circles, grayscale image. Okay, well that's not helpful to have grayscale, but anyway. Starting point. So already there's a couple of things. Import the random library. There are 2 libraries we need. Before I even go any further on this question, I want to get a couple of marks in. You know, I'm rushing at the end. Like say you're panicking the exam, you spent a long time on question 4. At least get 2 marks in here. Import turtle, import random. As soon as I see the word random, I know I have to get a random number using randint. So let's have a look. We've got our constants, we've got some global variables. Turtle mode standard, fine, screen width. Okay, so we've got a little bit more to do here. Right, so there's quite a lot to do here. Obviously turtle done is going to be at the very end. So we're way away from that point. Prepare the turtle including speed. I mean, they probably want us to put everything under these comments. I'll just leave that up here. Fine. Speed is usually 0 unless specified, and then we want to usually save the turtle into a variable that we can easily call. So we probably, to set up the turtle, we can literally say turtle like this. So we have to call the turtle method within the turtle module, and then we can just add all of that to a variable that we can use later, which just makes things easier. So we don't have to rewrite all of this every time. Then we can say speed method is 0. I guess pen up and just get it ready, so it's not drawing anything yet until we get to the right place. I think that's fine. That should be okay for setting it up. And now it's asking us to draw a line in A and B. Fine. So what is line A and B? We've got starting point. Lines are drawn in black and width of 3 units. So already I've got some information I can use. So turtle.pen size is 3. And then turtle dot pen color, and this is not in English spelling. American spelling and just put black. So that's dealing with that. And then I guess I have to set the position. So it's draw the lines A and B. So let's just draw the line A first. So I need to set position. And then I'll just take what they've done there, minus 200, 0. And then, let's just check I'm doing everything right. So line A is just the axis, line B is the axis. Fine, I think that's okay. So our pen is up at the moment. Set heading. Set heading to 0. And we want to put our pen down. And then we want to go forward. So if it's 200 and then 0, it's going to be 400, isn't it? Yeah, 0 is the quickest. If you put 0 in, it will be the quickest possible. So that's good. We did that already. All right. Okay, let's just go back to lines and make sure that we go as we go along. So we've got our position. We're setting our heading. We've put our pen down, ready to draw. And I think what we need to do is try going forward. 400. I'm pretty sure that's right. And then let's put our pen up once we've drawn a line. And let's run it. Okay, that looks good to me. We've drawn a horizontal line. So line A is done. Now we need to do, oh, it does say, look, 400 units long. I didn't have to guess. I was going off the difference between 200 and minus 200. Obviously that's fine. Okay, good. So we need to do the same sort of thing again. I'm just going to sort of copy this for line B. Now the set position is going to be 0, 200 this time. For line B, I'm going to put a comment in line B, line A, because it does ask explicitly to add comments. But the heading is going to be, so I'm at the end. I guess I need to go 270. And then pen down, forward, another 400. Let's just make sure that works. Fantastic, okay. Okay, that works. We've got our axis. Good. A and B are done. Now I need to draw lines C and D. To draw lines C and D, it's going to be very similar. So I'm just going to paste this again. Set position. It's minus 200, minus 200. And then it's saying, so C and D are 45 degrees. So I'm going to set the heading for 45 degrees. I'm going to put the pen down. And it says 566 units long. So I put 566 in there. And then pen up, I guess. I think that's fine. Yeah, that looks good to me. Happy with that. So now I need to do the same, but for D. And D is 200 minus 200. But the set heading is going to be a bit different. It's going to be, what's 180 minus 45 is 135. Let's check. Right, so I've got A, B, C and D. Now I've got to draw the circles. The circles are going to be more tricky. It's likely that we'll need a for loop for this. So there are 9 colour circles, fine. So I need to do something 9 times. So first of all, I need to set my heading to, the pen is up, and set the heading to 0 because I'll put turtle home. I mean, technically you can do turtle home like this. And then a for loop, so I can say for count in range of 9, because I need 9 things. It will do 0 to 8 and stop at 9. That's fine. So count will be 0, then it will go up to 8. And I've got a load of things up here, so I'm just going to copy this for a second and pop it down here in a triple quoted string, just so I can remind myself of what they were called, because I'm pretty sure I'm going to have to use them here. So for count in range of 9, I need to set the position of circle 1. There it is, location of circle 1. So let's set position, X position, Y position, because they're already stored in my variables. The pen has been up, it changes the heading, then I want, I guess, the pen to be down so I can start drawing. Now, yeah, already so it was circle 75, fine. So at some point I'm going to have, oops, circle 75. At some point I'm going to do that, and I'm also going to have pen up. I'm just trying to piece together bits that are easier. So my pen goes down, 1 dimensional, 9 circles are stored in a mind. Each colour is used in sequence. Peru, olive and gold. How's this going to work then? So I pen down, and then I need to do pen colour, and I need to do something tricky with this. Pen colour, so this is going to be my colours, but there's a little caveat to this. So which index do I want? I want them to change each time, so for each loop goes round, let's just check here. Let me read it. Colours will be the same each time the program is run. The width of the line is a random integer. Okay, so the colours aren't random, they go in order. So the turtle dot pen color, my colors, index. What have we got? Well, I've got this, haven't I? And then I can do modulo 3. So like 0 modulo 3, 1 modulo 3, 2 modulo 3, and then it's going to just cycle through these. So I think I've just solved my colour problem. It's a bit tricky, to be honest, but I think we solved it. And then I want pen size is at random, so I'm going to say pen size. That's going to be random integer between what it said 5 and 10, between 5 and 10. So I'm going to put 5 comma 10 in here. Okay, this isn't too bad, this bit, but this bit's quite tricky. For question 5 it's taking quite a while. Fine, I think we're close though. Let's just run it and see what happens first of all. So I think it's drawing all the circles, but we need to change the position. So when we have this X position thing and we have Y position, and I'm sure it says in the question, the second circle is located at plus 30. So let's just go with it, equals whatever that was, plus 30. Phew. So what I'll be doing now is probably adding a few more comments. I don't think I've really added enough comments. I've got some white space. It's a little bit better. Just spread it out a little bit. Yeah, make it breathe. Yeah, feel free to add a little bit of breathing space on all of this, just so it's not completely cramped up. Looks better already. And then what I'd be inclined to do is just add a few more comments in as I went, especially all this stuff here. I'd definitely add a comment. Something like that, in order. Ooh, okay. Done. I'm not doing any more on that one. A set of records is stored as a two-dimensional array. It's, well, yes, you can say array, but it should be called two-dimensional data structure technically, because these are records. Fine. The fields in each record are a key and a signal reading. And by the way, in real life you'd have dictionaries with key value pairs, but we don't use dictionaries in GCSE. We don't learn it, so that's why we're using Python lists. Right, a valid key has a minimum length of 3. A group of letters and digits ends with a valid digit. Fine. So what we need to be doing obviously is checking our validate our inputs with these keys and seeing if we get the right things out. I'm pretty sure this table will help us. A valid signal reading must be a real number, so that a real number would be a float decimal point. Okay, so we've got to build up our subroutines, and we've got to build up our main program from scratch here, which is not going to be easy. Let's just get in. Let's just get stuck in. So we've got we've got no libraries, we've got our constants, we've got global variables. We don't need any more global variables, I don't think. Otherwise it would have said. And then subprograms. So we need to make a subprogram. So we're talking about valid. A set of records. Fields in the record are a key. A valid key. So look, I mean, it really makes sense for us to have a subprogram called is key valid, camel case. Always put parentheses in their brackets, even if you haven't got a parameter, and then colon at the end. And we're always, I mean, if it's a function, we're going to return a value. It's highly likely that we're going to return something. But we do need something in here. So I'm going to put P for parameter and then key. Just to show the examiner that I know what a parameter is. That's something I need. What other checks are there? There will be a valid key, check digit. So I think we need to have another subprogram, that will check for digits. I'm just going to copy that. Oh, that's what we're going to call it. Check digit. And I think that's also going to be the key that we're going to pass through. So it makes sense that subprogram does each one of those things. And valid signal. There's three so far, three that I can think of. And that might not be a key, because that's the signal readings here. So I'm going to put signal. Right, okay, here we go. It's just to sort of map out and break our problem down into smaller steps before we do any more. So how can we check if a valid key, so I mean, it has a minimum length of 3, a group of letters and digits, and ends with a valid check digit. Okay, right. So length, let's just tackle it. So if it's a conditional statement, I might have to tidy this up. I'm going to put brackets in here. If the length of our key that we're passing through is greater than or equal to minimum key length, which is up in our constants. That's one bit I need. It's going to be quite a big one, so I'm going to put more brackets in there, because I've got lots of conditions to meet here, haven't I? So if it's greater than or equal to the minimum key length, I'm happy with that. And P key, we can do the method is alphanumeric, and that's in your PLS subset document. So you don't have to remember that, you just have to know what it does. If P key is alphanumeric and the length, let's have a look, length of the P key. Do we have any more to do? Ends with a digit, so let's check that. This is going to be pretty pretty long conditional statement here. P key so what's our P key? Is it 103? There's a 2 here, so they're essentially square brackets is indexing. So I'm probably going to have to put brackets in here. If the P key and then brackets the length of the P key, so how long it is, like 1, 2, 3, 4, 5, 6. Minus 1 to look at the last one, because we're 0 indexed, aren't we? So that's the index, just to find the last one. I think we can also do this as well, but I'm going to show you, I'm just going to leave it like that because I think it might make more sense to you. P key, length of the P key minus 1 is a digit. So again, this is in your PLS subset document. Are we done yet? Oh, it's quite lengthy right now, so let's just go through it. If the length is greater than or equal to the minimum key length, that's fine, that's for okay, and is alphanumeric, yeah, and the last digit, the last item in the key is a digit, I think we're okay for now. I have a funny feeling I might have to check for a bit more on this to make sure it's valid, but we're going to just go with it for now. I might have to check if the whole thing is alpha or the whole thing is digits. So we'll see. But essentially, if all of those things are in place, then I can say valid equals true, and then return valid. Okay, check, calculate to check digit. So here, what I want to be doing is checking. If we look at the question, the sum of the digits in the key, so like 7 plus 3 is 10, 2, 3, 5, only in the key. Right. The last number is a check digit. This is a complicated question. Let's have a look then. So we've got to keep a way of keeping track of our index here. Depending on what kind of loop we use, we have to iterate, and we'll have total equals 0, just to initialize those with integers. And it might be best that we use a while loop here instead of a for loop. So we can say while, I'll make some space here, index, which we're going to update each time, is less than the length of our key minus 2, because we don't want to look at the last value because that's a check digit. So as long as, and I'm going to put those in brackets as well, that's our condition. As long as index is less than the length of the key minus 2, so like 1, 2, 3, 4, 5, 6. Sorry, no, 1, 2, 3, 4, 5, sorry. Then we can say if p key at index is a digit, if it is a digit, then we can add it to our total. Because if it's a letter, obviously we ignore it. Equals total plus integer, and then we want here p key index. Okay, because it is a string, and we want to make sure we change that to an integer. And then we want to increment the index every time we go around. So index, you can either do plus equals 1 or safer index plus 1. They both mean the same thing. Just to show you would need to add comments for all of this. I'm just going to concentrate on the program for now. And return well, we're not ready to return anything yet, so we've added up our total, and it says check digit equals rightmost digit of the sum. So for 10 it's a 0, and for 13 it's a 3, so we only want the last one. So check digit is going to be equal, what's that going to be equal? So we can say, let's look at our total. We've got a total then. If it is we're traversing through the index of our p key, and then if it's a digit, we can add it to our total. Then we can say total equals, no, string total equals just converting what we've got into a string, and then what we're going to do is the digit is going to be equals string total indexing the length of the string total minus 1 to get the last value. And this works for any length of string. I do think just having minus 1 will probably work, but I'm just putting length string total minus 1 in there. I think that's enough. Right. So how do we know if a signal is valid? Well, we've got these two, max signal and min signal. So what we want to be doing, we've got a parameter p signal. So let's start off by saying valid equals false until we can prove otherwise, and we'll return valid at the end. So here, if p signal, our parameter, is greater than or equal to the maximum signal, I'm going to put these in brackets, and I'm going to put a bigger bracket in here, and p signal is less than or equal to minimum signal, like less than or equal to 1. Yeah, putting brackets in here really helps. Return, then I can say valid equals true, and then return valid. Whew. So we've got through our, I think we've got through our sub programs at least, and now we need to make the main program. I mean, we've spent a long time on this exam already, but let's do it. This is the final furlong. Let's go. So main program. So we want to traverse now with a for each loop, just to go for each record. So for record in the records, so the key is this bit. We can say the key part of it equals record at index 0, because index 0 is the first item. It's like this. Each record, like that's going to be the first time the first record it looks at. That's the second time, index 1, and then inside that, that's index 0. That's index 1. So 1 0 1 1 0 0 0 1. And then the signal part equals record to the power to 1, not to the power. And then what we want to do here is just check this. So I guess we can get the check digit location. And that's going to be the length of the key part minus 1. That's the location of where it is, where the check digit would be. And then we can say the check digit is an empty string so far, and here we can go and say empty string to compare, and here we start to use conditional statements. So if is key valid, so if that returns true, and then what's our argument is the key part, that's what we're passing through there as p key. Then we can do check digit. So as long as the key is valid, then we can do the next bit. Check digit we're going to need this. We can say check digit equals, calculate the check digit, and I guess location we pass through here as the argument to check the digit. And then if the check digit, oh hang on, is key valid, yes, then check digit, yeah, I'm quite happy with that, I think that's fine. I don't think that's right because we need the whole key, don't we? We need the key. So I want key part. So I'm calling the function and I'm passing the argument the key through here. That's why we need the key. Yeah, right. Fine, and that's going to return the check digit. So then I can say if the check digit equals key part location, under index, if the check digit does equal the location from the key part, then I can say if is signal valid, I'm going to have to pass signal part through that as a parameter. So if not is signal valid, if it's not true, then I can print invalid signal. Else print invalid key. Let's put record in there. Yeah, we can tell it's invalid. And then else out of here, invalid key. Right. Got some problems. Right, where is it? Cannot access local variable valid. So it is key valid, that's the key part, that's fine. I mean, we've got a local variable. I'm pretty sure that's indented correctly. Right, just give me a second to look at this. Yeah, it's having a problem in line 29. It's because if this condition never is met, it doesn't know what valid is as a local variable. So I'm going to say valid equals false, and that's why I should always declare those local variables with a data type first. So now invalid key invalid signal how many so I just quickly had a look at the mark scheme, and it looks as though I've got too many of these. I should only have 12, and I think it's to do with this. And I think it's because I need to have more validation. So what I probably want to be doing is checking that they're not all alpha or digits, like if they're all letters or all digits. So I'm going to put brackets in here. This is going to be quite long. So I'm going to say not P key, and then from 0 to the length of P key minus 1 as our index. So that's basically all of it except the last one. All of it. Sorry, every single one, because we start index from 0 and it goes up to the last digit, the last thing. As long as that is alpha, it's not is alpha essentially, so it's not all alpha basically. I'm checking here. The not means it's a negator, it's the opposite. So I'm gonna, this could get tricky. Not and not P key 0 to length P key minus 1 index is digit. Let's try that. So I'm basically checking if they're not all digits or alpha. I'm going to leave it there. I think that'll be enough to get the vast majority of marks there. I've done a huge amount of work in that one. I'm not 100% happy with it, but I think for an hour and 20-minute video, that should be enough to certainly get your 9 in that exam. So all the best with it. That was a pretty brutal question, quite fiddly, but good luck, and if it's helped, let me know.